Hey everybody, it's Mrs. C, and I am coming to you with a little Let's Practice video on dividing exponents, or dividing, I guess you would say, dividing monomials with exponents. I'm trying to find the proper terminology. I'm also setting my pen so that I can write. So dividing with exponents. Now, there are many laws of exponents, and the one that many of you are coming to is the one that's the quotient rule. And the quotient rule is dealing with problems that look like this. Let's say we have 2x squared, maybe a y to the 5th, over, 6x to the 5th, y squared. I know I picked 5s and 2s. Sorry about that. And so what you're being asked to do is simplify. That's pretty much what we're always being asked to do. And the explanation of the rule, or the actual definition of the rule, it's a little confusing in my opinion. So I just thought I would show you a very simple way to kind of understand what's happening. And then I'll tell you the trick, I guess you could say, of what's happening. If you want to understand the quotient rule, what you need to do is go ahead and give me the prime factorization of the numerator and denominator. And I know I just saw a bunch of you roll your eyes at me because I said prime factorization, and you had bad memories of the past when you were asked to do prime factorization. Oh, just chill out a little bit. Prime factorization just means to write the number as broken down as you can make it into factors of its primes. So if I was to ask you to give me the prime factorization of 2, 2 is a prime number. So you don't have to give me a prime factorization of 2. Now, x squared is in essence x times x. Write it in expanded form. Break it down to its very basics. Now, can you handle that? You can handle that, right? X squared broken down or broken apart is x times x. And I bet you can even tell me y to the 5th. It's y times y times y times y times... I just lost track of all my y's, and I don't really need the dots, but I'll put them for today. 1, 2, 3, 4, 5. 5 y's. Now, you do 6. How do you break 6? Remember the little factor trees? Yeah, you do. Your little prime factorization trees. How do you break 6 down into factors that are prime? Well, you would say, hopefully not 6 and 1, because 6 isn't prime. You'd say 2 and 3, because both 2 and 3 are prime. So there's your prime factorization of 6. And now, you can do that in your head, but I just thought I would write it down for you. Can you break down x to the 5th? X, 5 x's. And y. All right. Do you see what I've done? I hope you can. I've broken these apart. I've expanded them out so that they're in their most primal way. I have lack of a good word for that, but we'll just expand them out. Now that we've done this, what the heck are we supposed to do? You might be thinking, great, awesomeness, but what am I supposed to do? All right. You look at them in their most broken down way, in this expanded form, and you say, do I see any common factors like 2 and 2? Well, in division, 2 divided by 2 is 1. And so in the past, when you have found common factors, you've said 2 goes into 2, 1, 2 goes into 2, 1. I know, you're like, oh, yeah, I do remember doing that. Of course you do. Are the ones important now? I don't think they are. I think you know that there's a 1 there, and that 1 when we times isn't going to matter. So I would prefer, actually, if you don't mind, if you just don't write the 1, because less is more. The more we write, the more complicated it's going to get. So less isn't more, less is less. Now, do you see any other 3s? No. So I can't cancel the 3 out with anybody else. 3 stays. How about x's? X here, out. X here, out. X here, any other x's? No. So these 3 x's are going to stay. How about the y? Y here, y here, y here. Any other y's? No, except only on the top. So these y's stay. There's no other y to cancel out with them. And so now, believe it or not, you're done. I just have to write the answer. Now I'm going to erase my little 6 factor tree, and I'm going to write the answer up here because I don't have a whole lot of space. And so, what would you say I would write that is in the top, in the numerator, that I didn't cancel out? What's left? These 3 y's. Now, I don't like that pen color. 3 y's that are being times together are not written as the 3 y's, right? We would write y cubed. It's easier to write, it's smaller, it's less confusing. Now look down in the denominator. Who got left? There's a 3. And there's nobody else. Nope, there is. Look at these guys. There's 3 x's. That would be written as x cubed. That's it. That is the quotient law of quotient of division of exponents law. All right, now, that's not really what they call it, but that's the Mrs. C version. That was the expanded form. You're probably thinking, are you kidding me? I can't write that. That's craziness to write that. Of course it is. Nobody would really write that all the time, just until you understand. So look at it. 2 goes into 2, 1. 2 goes into 6, 3 times. That's what we taught you to do in like 5th grade. Then you look up here. I've got an x squared, not a 2x squared, but I have 2 as an exponent here, and I have 5 down here. So when I go cancel them out, where will the extra be? The extra will be in the denominator because 5 minus 2 is going to be 3. So these will all cancel out, and there will be 3 left. Same thing here. These 2 will cancel out, and you can really you're just minusing the 2 from that, leaving you 3 up here, which would be a y cubed. Then you see how messy that is. You have to rewrite. I didn't mean to do that. Sorry. Oof, I thought I lost it. You have to rewrite the numerator, which is a 1y cubed, and we already did that. And then rewrite what's left in the denominator, 3x cubed. Okay, you see, I know you're thinking, no, so I'm confused. Well, let's just try another one. I'm going to write another problem for you. Hang on a minute. Okay, I wrote another one for you right here. So what do you think? Let's go ahead. Now, you do not have to break this down. I want you to try doing it without breaking it down. But I want to caution you. Do you see the little a that doesn't have an exponent? You see it here, right? Right here. I'm going to caution you that if you don't have an exponent showing, write a 1, because there's a lot of people that'll write and assume that that's not there, that it's a 0, and that's not the case. If you have any number and it's not showing that it's being raised to a power, then the implied power is 1, because there is one little a there. So now we cancel, and we're going to try this, and then that's going to be it. I'm not going to do any more for you. It's just a little quick, let's practice. So common factor of 6 and 4. Anybody? Anybody? That's right. It's a 2. 2 goes into 6, 3. 2 goes into 4, 2 times. Now, if I had, moving on to the a's, if I have 2 a's here and 1 a here, when they cancel, there's going to be 1 a left in the numerator, because I would do 2 minus 1, and that would be a to the 1. So there is 1a left in the numerator. Now let's do the same thing. I have 5 here. I have 7 here. I'll have the extra, and the extra will be in the denominator because the exponent in the denominator is bigger. So I would minus the 5 from the 7 and get 2. That is how many b's I would have left. I would have 2 b's. Two b's timesing to each other, otherwise known as b squared. Now look at this next one, c cubed, c cubed. Anything above and below that is the same cancels out because it is its own common factor. You could actually say 3 minus 3 and see that you have 0. There are no c's being raised to a power. Now we're going to see in the future that any number raised to a power is 1, not any exponent, but the actual value of c to the 0 is 1. But I'd caution you not to worry about that right now. Haven't gotten that far. Those will cancel out, right? Absolutely. So the final answer, let's check out the numerator. There's a 3. I'm up here. There's a 3. There's an A. There is no B in the numerator. There is no C in the numerator. Let's go down to the denominator. There is a 2. There is no A. There is a B squared. There is no C. Final answer, 3A over 2B squared. All right, guys, this is enough to get you started, to give you an idea. This is by no means the end or even close to the end of the things that you will see when you are working with exponents and the quotient rule. But it is the very basic, and knowing this is enough to tackle the other ones slow and steady. So I hope this cleared some things up, gave you a little bit of an idea of how to go about solving these. And what we have to do now is a whole lot of practice. Again, if you're looking for some practice, you know my favorite site, CUDA. Go to CUDA, check out their division of exponent practice, and do some of that. Bring it back in class, and we'll work it together. All right, guys, see you on the flip side.